So, patterning control. Let's see this first video of this series regarding the patterning control. Specifically, we will see the effect of temperature. When we talk about temperature and patterning, we refer to the temperature of the resistance that heats the tip, so what we call the writer. So the temperature that we set from the NanoFraser software is the temperature of this resistance, but the temperature at the interface between the tip and the substrate is going to be, of course, different and always lower than the temperature that we set at the writer. So it's something, of course, good to keep in mind every time we use the NanoFraser. And as you can imagine, since when we pattern we have to sublimate the PPA, it's it can be straightforward to think that if we increase the temperature, then we increase the thermal energy in the system, so we can sublimate more PPA, so we can, say, write more efficiently. So this is just in very few words main concept to keep in mind regarding the temperature. Let's move towards the NanoFraser software to see more in detail how we can play with temperature to optimize our pattern and what is the effect of temperature when we pattern. So I have some layouts that are loaded here. We can start with the sine wave, a layout that we already saw in some previous videos. It's a 3D or grayscale lithography, so we have a force that's changing. For the sake of simplicity, we will remove the feedback because we want to just see the effect of temperature when we pattern. So let's put a force that's changing between 3 and 4 volt. In this case, we had this option checked. So we have a read height, scan height very large, because when we increase the temperature, we may pattern very deep. So we want to be able to read the bottom of our pattern. Here we're also quite close to the edge of our sample, so maybe let's move a little bit towards the center. Since we are moving quite a lot, it's a good practice to redo the TSPL configuration, especially the sample level plane can change a little bit if we move by large distances. So you can see the quality of this tip. We have a very sharp tip, around 9 nanometers. No, sorry, around 5 nanometers adhesion length. Yeah, we're good to go. We can start patterning the sine wave with a feedback disabled, a force that ranges from 3 to 4, and forward height 250. Initial temperature is 950, which is the standard temperature that we usually use to pattern on PPA. And this, let's not forget, the sample that we're using is 10% PPA, spin coated at 4K RPM for 40 seconds on top of silicon. So we have a very large thickness of PPA. So we see already that with the force that oscillates between 3 to 4, we are patterning very deep. Maybe we can reduce and put the force between 1 and 2. Okay, and let's change the temperature now and see practically what happens. We put 1050, we increase the temperature now, so we expect to pattern deeper. we can increase to 1150. It should be patterning even deeper now. Now we're probably having some issues with some contamination, so we may have some cleaning of the tip. Let's put it to 1250, which allows the pattern even deeper and deeper. Here probably we were able to clean the tip, and if we put it on the other hand to a temperature that's below the 950, we will pattern much less efficiently. Here we are not even able to pattern with this force. So in this case here we were able to see probably we grabbed some contaminations, and then after we increase the temperature we're probably able to clean the tip again. So we could see live the effect of increasing the temperature on this sine wave, but let's also see on another design which is more visually appealing, I will say, for understanding more the effect of the temperature. So I would like to show you a design through the temperature maps. We will also have a video that discusses the temperature map functionality and laser power map in detail. But so what are we talking about? So we have this design, which is I made it a 2D design. I can make any design 2D by just pressing the 2D here, and you can see this was the original design, something like this. But then I said, okay, let's make it 2D. So 1515, same height of patterning. We keep a pixel size of 20, which is good for us. And I have already imported this design as TSPL2, which you can see here, TSPL2. What we want to do is now applying a temperature map on top of this design. To apply a temperature map, we go to the temperature map tool, we select our field, and on top of this field we apply the same field, which we can open from our geometries. So we select it and we resize this and replace in this target field. So basically this 2D design, 2D is referred to the force, right? So if we pattern with the feedback, for example, we will use pretty much a constant force, or we can just pattern without feedback with a constant force. That's pretty much what the software would like to see. But if we apply on top a temperature map, then we will tell the software to change the temperature pixel by pixel. As we move towards the top of the field, we will see that we increase gradually the temperature. So we start from a temperature of 500, and we will increase to 1300, which is already quite high temperatures for patterning. Usually we recommend to stay around 950, 1000, so to avoid burning or damaging the resistance of the writer, because we're talking about a region of a semiconductor which is doped. So if we increase temperature to very high values like 1300, 1400 for a very long time, we can change the doping concentration, the doping profile in this region, and we can damage the resistance. Eventually we can also burn the resistance. So 1300 is quite a high temperature. And we have 4x4 area, so 16 squares. We should see an increase of temperature by 50 for every square. So 500, 550, 600, 650, up to the final value of 1300, pretty much. So now we are good to go. In order to use the temperature map, we have to check this box, use temperature maps, and we want to disable the feedback, so we put 1.5 volt, and we can start. Just to double check, our tip seems like it's a decent shape. Let's see, it's gonna take around 3 minutes, and if everything works well, we should be able to see a good effect of the temperature while patterning on insulating substrates. Sorry, not insulating substrate. In this case, we're not patterning on an insulating substrate, but I got confused because this is a functionality that is often used to pattern on insulating substrate. So in this case, we're patterning on silicon, so which is a semiconductor. Okay, so we see for these initial squares, so here the temperature is too low to pattern. We are 500, 550, 600, 650, so between 500 and 700 we are not able to pattern. Still, even on the above squares we cannot see much, maybe a little bit of indentation finally here. It's not really patterning, I would say, but it's more like indentation in this area. And here we're talking about 700 to 850 pretty much, and hopefully from the next field we should be able to see some pattern area. Okay, yeah, finally we see something, so it's very clear. When we are at around the temperature which is 850, 900, we start writing. Also, I don't know exactly the temperature in each square. I suppose we have a change of around 50, but this template was not designed to have a constant change of let's say 50 or the same value for each square. So approximately here I will say we are at around 850 Celsius, and we see that when we move to very high temperature, so here we basically using a 0 force, not zero but very little, and when we reach 1300 Celsius we have a much deeper depth of patterning. I think this is a very nice example to show you the effect on patterning, the effect of temperature while patterning. In general, I will recommend to play with the temperature as first things. So if you see that you're struggling patterning some specific designs, the first thing that we will change are the temperature and the force. And especially if you see that the forces that you're using to pattern are getting very large, so in the right range of this box, around 9 volt, it's easy to saturate, so we tend to increase the temperature in these cases to give a little bit more help to remove the PPA with more thermal energy. And yeah, so this is pretty much it for the explanation of the effect of temperature on patterning. I hope this can help you in understanding a little bit more how to play with this parameter, and we will see also other parameters in the following videos.